Cikgu sepatutnya buat under assignment lah. So you try and enclose lah, ambil gambar saja dan hantar. Nanti cikgu senang, cikgu tanda. I just want to see. So pastikan yang kamu faham lah apa yang kamu buat. Okay, now for experiment 2. Wait, just give me a minute. Kita akan lihat experiment 2. Okay, we go through first, kita punya eksperimen 2. Kemudian we will go through the pre-lab questions ya. Okay, so untuk eksperimen 2 ni adalah eksperimen yang penting ya. Because every time during exam, masa ada assessment tu, they will ask this titration lah sebagai cara untuk melakukan eksperimen masa lab. Tetapi untuk kamu kali ni, since you are going to study from home, there will be a way of assessing it. Okay, so kamu cuba fahamkan betul-betul, and lab report ni adalah sangat penting kamu hantar pada saya lah, so that I can check your mistakes. Okay, so demonstrate the correct techniques in handling laboratory apparatus and chemicals when carrying out experiment. Okay, so at the end of this lesson, students should be able to prepare a standard solution of oxalic acid. Okay, so this is where your skills lah. Kita nak sediakan a standard solution. And then standardize the 0.2 NaOH. Determine the concentration. See, concentration of HCl and the correct techniques lah. So there are 4 things here that we want to see into. Sekejap ya, ada orang nak masuk. Okay, so these are the 4 learning outcomes that we want to see. So titration is a laboratory technique used to determine the concentration of a solution using another solution with a known concentration. So the main aim here is we want to determine the concentration. We want to determine a concentration using another solution of known concentration. Okay, one of the solution involved in a titration is used as a standard solution. The standard solution can be classified either as primary or secondary. So standard ni ada 2. So if a primary standard solution is prepared by dissolving an accurately weighed solid of a known molar in a known volume of distilled water. A primary standard is used to determine the molarity of another solution known as secondary. For example, in this experiment, oxalic acid are known as 2 primary standard solution. The NaOH solution used in titration need to be standardized because they contain impurity. Okay, so but this one, the standardization is done by the lab assistant. So nothing for you to worry. Dia memang akan sediakan. So you just tugas kamu untuk masuk dalam your burette. Okay, so now let me have siapa? Nabil, can you read the equivalent point and end point?
An equivalence point is the point in a titration at which the added titrant reacts completely with the electrolyte according to stoichiometry. To detect the equivalence point, an indicator which produces a change in color is often used. The point at which the indicator changes color is called the endpoint. The endpoint and equivalence point should ideally be the same.
Okay, thank you. So these 2 terms, when we do titration, you cannot run away from these 2 terms. They will love to ask you what is equivalent point and what is end point. So kalau equivalent point is the point in which the added titrant reacts, okay? Added titrant reacts completely with the electrolyte. According to apa? Stoichiometry. This whole week you will learn a lot about, you will dengar istilah stoichio banyak lah. We'll say stoichiometry ya. Okay, so we will see that. Endpoint ialah bila indicator tu changes color. Here usually we use phenolphthalein. So both this you must know. Equivalent point is the point at which the added titan reacts completely with the electrolyte according to stoichiometry. And endpoint is the point at which the indicator changes color. Okay, so if you look at this equation, this is equation for neutralization. When I say neutralization, what must you have in the equation, Azwa, Nurul Azwa?
Yes, madam.
What must you have? What do you understand by neutralization?
Mix between acid and base.
Okay, there is a mixture between acid and base. Okay, so kita tengok sekarang. I will just go through first this part of it. Okay, first thing yang kita nak buat is we are going to prepare a standard solution. So what we will do is we will weigh 3 grams of hydrated oxalic acid. So when you go in, you ada apa? What do you have? Analytical balance. So you get into the analytical balance here. Masukkan you punya crucible. And you will weigh 3 grams of oxalic acid. Okay. In a 50 ml beaker. Sorry, bukan crucible. Tukar 50 ml beaker. 50. Okay. And then what you will do is add approximately 30 ml of distilled water. So kat dalam ni kita ada oxalic acid. You have oxalic acid here. 3 grams. You will add 30 ml of distilled water. The reason for the distilled water is for you to dissolve it. So guna glass rod and you stir. Mama. Okay, so you distill, use the glass rod and stir. Then what you will do is you will transfer this solution into a volumetric flask. Ini adalah volumetric flask. Like this. Volumetric flask bulat macam ni ya. So this is a 250 ml volumetric flask. Check your drawing sama ada kamu ada lukis betul tak. So bila you masuk volumetric flask ni, kita akan ada benda ni. What do we call this? What is it?
Funnel.
Yes, filter funnel. And sometimes we do put in the glass rod here, and then we plug. This is the glass rod, and you will pour this solution in through the using the glass rod. You mengalirkan dia. And if you see in a volumetric flask, there will be the calibrated mark. Kat sini akan ada mark. This mark is called the calibrated mark. So bila you dah isi katakan macam ni, nearing the calibrated mark, you must use a dropper. Try and use a dropper. Kat dalam ni ada distilled water. This is a dropper. Okay, so kita kena masukkan dropper to make sure that kita punya meniscus ni is exactly on the calibrated mark. Kalau dia lebih daripada itu, kamu kena buat semula start from 3 gram ni. Tengoklah punyalah payah kan kerja tu. You have to go back, weigh again, dissolve again and put it into the volumetric flask. So you have to be very precise lah bila buat Ramai student yang memang akan terlepas calibrated mark. Sebab dia guna distill water bottle, main tekan saja, terlebih calibrated mark. Kemudian dia ingat cikgu tak tahu, they go and pour, then they say, teacher, cannot because the concentration akan berubah nanti. Okay, once you have got to the calibrated mark, you will put a stopper and you will shake the solution. Why do you shake the solution? To get a homogeneous mixture. Once you are done with this part, that means you have prepared the oxalic acid, the standard solution. So your standard solution here is the oxalic acid. Ada apa-apa soalan? Tak ada? Okay, I will just let you view a little bit of the video. Just give me a minute. Tak apa, kita view kemudian because I need to get the link first. Okay. Next, standardization of 0.2 molar NaOH. Rinse the burette with an given NaOH solution to be standardized. Fill the burette with NaOH solution. Ensure there is no air bubble. Okay, this is very important. When you get a burette is a long thing like this kan. Kita ada, we have this. This is the burette. So what you will do is, you akan masukkan dulu distill water. You will turn it round so that the solution, distill water yang kamu masuk ni boleh mengalir macam ni lah. While you are rinsing the walls of the burette. And then you can drain it out sini. Boleh keluarkan sini. Or you can also keluarkan here. Okay, you discard the water. Discard the distilled water. Sini atau sini. So once you have rinsed your solution, dalam lab ni, apa-apa apparatus that we use, we have to wash it using distilled water. Okay? And then we will add in the NaOH. Bila kamu nak add NaOH, ini adalah your lab table. Okay? Here there will be the sink. So what you will do is, you will use a retort stand. This is the retort stand. You will clamp. Ini ada clamp, clamp. You boleh clamp the burette this way, so that dia adalah dalam sinki lah, dalam sinki ni. And then you use a filter funnel, and you will pour the NaOH in. Boleh guna glass rod also. Dia kena mengalir melalui glass rod. Why? So that you don't want dia terpercik. If it goes through the glass rod, it will go exactly in. Okay? And then you fill in. Once you are done with it, baru boleh turn it to the other side. Never mind. After this, I show you the video. For burette, yang paling penting ialah this part of the burette. Where there is the pili, we must make sure no air bubble. If there is air bubble, dia akan affect kita punya bacaan nanti. Okay, don't worry. As we view the video, then you will understand what I'm trying to say. So always remember, when we talk about burette, ensure there is no air bubbles trapped at the tip. Ni penting. Ni adalah safety precaution also. Once you have recorded the initial reading, always remember burette ni is 2 decimal places. Dia punya bacaan ialah 2 decimal places. Okay, next comes in the pipette. Remember tadi kamu dah sediakan oxalic acid kan? Kamu ada oxalic acid dalam sini. Macam ni. Ini kan, kamu dah ada oxalic acid. So what you must do, oxalic acid ni, kamu tuang dia ke dalam sebuah beaker, 50 ml beaker. You will use a pipette. Pipette. Pernah guna pipette tak kat sekolah?
Pernah, madam.
Pernah kan? Very good. Okay. So this is the pipette. You will pipette the solution. You kena ada 25 ml. 25 ml. You akan masukkan dia ke dalam conical flask. Ini adalah conical flask. Conical flask ni kena buat 4 kali lah. Satu adalah bacaan gross. Gross ni adalah bacaan kasar. Kita tak akan ambil kira dia. Then first reading, then second reading and third reading. So eksperimen tu kita kena buat 4 kali. Gross 1, 2, 3. Okay, titrate the acid with NaOH. Bila kamu dah pipette ni, this is very important steps, please see. Pipette 25 ml oxalic acid into a 250 ml conical flask. Kena add 2 drops of phenolphthalein. Phenolphthalein is the indicator. Tadi remember you belajar yang equivalent point dengan end point? So there is the end point. Kalau 2 drops of phenolphthalein, and then you will have a white tile underneath the flask. Why do you need a white tile underneath the flask? Siapa cikgu nak tanya? Shazwina. Why do you need a white tile underneath the flask?
To see the color changes.
Correct. To see, very good. To see the color changes. So bila you dapat end point tu, you will get a pale pink solution. So kalau pale pink, nampaklah kat white tile tu. Okay, titrate the acid with NaOH solution from the burette. During titration, swirl the flask continuously. Rinse the underneath solution. Yang ni pun adalah precaution, penting ni pun kena tahu. Rinse the underneath of the solution at the inner wall of the conical flask and tip. Lepas ni kita tengok video. Upon reaching the end point, a temporary pink solution appears, but fades when solution swirl. Continue titrating until a pale pink persists for 30 seconds. Baru adalah end point. Pale pink yang kita dapat tu, dia kena kekal untuk 30 saat. Kalau dia berubah, itu bukan end point. Okay, so it has to change, it has to maintain for 30 seconds. And then you record the final reading. Dia nampak macam ni but once you have done, then it's okay. Then determination of the molar concentration of HCl. So untuk ni kita pipette 25 ml of given HCl. Ini dah adalah dalam delivery. 250 flask, again the same thing. Add 2 drops and then you titrate until dia berubah warna. See, this is the reading. So you will have 2 types of titration. You akan buat titration 4 kali. 2 orang akan buat 1 eksperimen. So you can take turns lah. You buat 1, kawan buat 1. You buat 1, kawan buat 1. And then you will do all this calculation. So minggu ni is just roughly I'm giving you the idea. Minggu depan is when we will carry out the experiment lah. Masa tu cikgu akan tunjuk video. Then I want you to take note of all the steps. So kalau ada apa-apa yang tak faham, boleh tanya. Tapi minggu ni sekarang, lepas ni pergi buat jota. You have to prepare the lab report sehingga the sebelum result table. Okay, so now let's have a look at this part of it. Define molarity. What is molarity? Hello, tak panggil nama juga.
The number of moles of solute in 1 liter of solute.
Okay, correct. Molarity is the number of moles of solute per liter of solution. Kena ada perkataan liter. What is, cikgu panggil nama sekarang wait. Thank you. Yang answer tadi Lakshan kan? Okay, sekarang cikgu panggil Giri. What is a standard solution?
Standard solution is a solution that has known concentration.
Accurately known concentration. Okay, and what is the use of a standard solution? So what is the use of the standard solution, Farhan Haziq? Farhan, what is the use of the standard solution? What is the use of the standard solution? Standard solution is used to, tengok tadi ada.
Used to standardize acid against base.
Standardized acid against base. No, there was a very accurate answer for standard solution.
To determine the concentration of other substances.
Yes, you see here, very precisely given in your manual. Kena ingat where is it? Here. See standard solution. Standard solution can we go? Okay. This is the one, the answer. Is used to determine the molarity of other solutions known as secondary. Secondary standard concentration basis. Primary standard used to determine the... Wait, where was it there? They said that accurately. Wait, ada kat sini. So is this part is used to determine the molarity of another solution of unknown concentration. Where was that? Tadi ada kan? So this is the function lah. You will know, and it is used to determine the unknown. Okay, a standard solution is used to determine the concentration, molarity of another substance, such as a solution in titration. So standard punya, it's like this, you must understand. This one, standard is in the volumetric flask. This is your volume, sorry. Volumetric flask. This is your standard solution. Here, we will know its concentration. But in the conical flask, we will try and determine what is the concentration. Okay, so we use the standard solution to determine the molarity of another solution of unknown concentration. Boleh kah? Okay. What is the difference between endpoint and equivalent point? Dah ada kat sana. So endpoint is when what happens? Let's ask the girls.
Color change.
Okay, the indicator changes color. Indicator, guna perkataan indicator. The indicator changes color. Whereas equivalent point, what is equivalent point? Equivalent point is the point at which the two reagents reaction occurs between the two reactants according to stoichiometry. So equivalent point kan, kalau kita nak jadikan dia lebih senang, moles of acid sama dengan moles of base, okay, stoichiometrically. Stoichiometrically, dia telah bertindak balas secara stoichiometrik. So not means equal lah, dia kena ikut pada equation. If say 1 mole reacts with 2 moles of base, so kena ikut lah, ikut stoichiometry dia, 1 mole acid katakan. So we have to follow the stoichiometry. How we know how many moles? Kena tulis equation yang balance. Balance equation. So you see all this you are learning already during your tutorial. So first thing you must know how to write the balance equation. Bila dah tahu tulis balance equation, baru boleh kira dia punya stoichiometry. So that is how we connect your tutorial and your lab. Okay. So we will see here. Next. State the 3 precaution steps to ensure the accuracy of the result. Let's see siapa yang nak cuba. Let me see who can I call. Anissa, Aisyah.
To ensure there are no air bubbles trapped at the burette tip.
Okay. So because what will the air bubbles do?
Affect the volume
The volume of the
of the
NaOH.
NaOH.
Yes, correct. So you must make sure that there is no air bubbles at the tip of the burette. So kalau ada, what you must do is you must drain out the solution fast. Cepat-cepat buka, pilih, keluarkan, tutup, buka sehingga air bubble tu keluar. Kadang-kadang it's very stubborn, you kena jentik dia. Okay? Just use your finger and flick. We use the word flick, F-L-I-C-K. Flick the tip of the burette so that air bubble tu boleh keluar. Tetapi if you have done both those and dia masih lagi tak keluar, angkat tangan, beritahu saja pada pensyarah, Madam, there is an air bubble here. I have tried draining out and I've already flicked also the tip, but the air bubble is very stubborn. So dia akan tukar burette untuk kamu. Boleh tukar burette. Okay, next let's have Syuhada. What else is your precaution step, girl? Mana Syuhada? Syuhada, where are you? Okay, Putri, are you? Give me another.
The eye level must be perpendicular at the bottom of meniscus level to avoid parallax error.
Okay, so where do you take the reading? At the top of the meniscus or the bottom of the meniscus?
The bottom.
Bottom. Okay, so your eye must be at the eye level lah. Your eye and the meniscus reading must be at eye level, so you can see it accurately. Okay, very good. Next, let's have Omar.
Yes, madam.
Give me another precaution step, boy.
Upon reaching the endpoint, titrate slowly until a pale pink color persists for more than 30 seconds.
Okay. Nampak macam skema je, semua orang dah okay dah tahu So you know already roughly. So always remember like what Omar said, good. You must make sure that the endpoint persists for 30 seconds or more. Okay, kalau dia not 30 seconds, that means it's not the endpoint. Okay, now reading how to answer, how to prepare 250 ml of standard solution. Okay, dia sama macam oxalic tu, tapi kali ni kita nak sediakan 250 ml of 0.25 molar. So what must you do first? Omar, please call somebody. Omar, kenapa gambar siapa tu, Omar?
Gambar saya.
Gambar kamu?
Yes.
Okay. Photoshop. But your hair is not like this, right?
Yeah, no.
No, okay. Don't give me heart attack lah pagi-pagi kan. Okay. Call somebody.
Syafiq Hamdani.
Syafiq. Okay, Syafiq. How would you do this, boy?
Yes, madam. Okay. This one just roughly take the point one.
Okay.
Like simply answer it in point.
Have you written it? Can you WhatsApp your answer? Let me.
No, but I got the answer. I mean, I still can think the answer.
You can think the answer. I asked you all to write the answer.
Oh, right now?
Not right now. Right before at 8 o'clock to 8:30.
Oh, because that time saya tak sempat, madam.
You buat your book Okey, tak apa. Siapa yang boleh bantu Syafiq? Siapa yang dah tulis step dia? Okay, Syafiq, then never mind. Okay, say what's in your mind.
Okay, first, like the dry volumetric flask, we put oxalic acid about 1.5, I guess, gram. Put in
Okay, how did you get this 1.5 gram tu?
weight on penimbang.
Based on penimbang. Tapi kenapa kamu nak guna 1.5 gram dan bukan 3 gram ke 4 gram ke? Macam mana you dapat kira gram tu?
Because when we need when 250 ml,
250 ml. What's your concentration?
Concentration of
What are you preparing?
oxalic acid.
So you are going to prepare oxalic acid. So macam mana you nak tentukan mass dia? What's the formula?
What's the formula? Because this thing macam I think like roughly lah, tak ada macam specific. Just put macam tu je.
Oh, just put macam tu je. Tak, yang ni kan tengok soalan dia. Briefly describe how you would want to prepare a 0.25 molar 250 ml oxalic acid. So yang ini dia sama seperti tadi. So what you need to do now here is you kena tahu formula dia. Molarity is moles of oxalic bahagi dengan volume of solution in liter. So molarity dia you dah tahu 0.25 molar. Volume pun you dah tahu it is 0.25 liter. So mole is mass bahagi molar mass. So dapatkan molar mass untuk oxalic acid. Oxalic acid formula dia dah bagi. Ini adalah oxalic acid punya formula. So dapatkan molar mass dia. What is the molar mass? Anyone calculated?
The molar mass is 6.25 times 10 × 10.
That is the moles, boy. What's the molar mass?
Molar mass is 126.
126. Okay, you akan dapat molar mass dia adalah 126. Kira ni ya, kena pandai kira. Molar mass 2 times 12 plus 2 times 1 plus 4 times 16 plus 2 times 2 plus 1 plus 16. Okay, so you are supposed to get 126. So bila you buat formula ni sekarang, you boleh dapat mass. Mass is like what Lakshan said, it is 6.25 moles dia. Is it the moles? Is it the mass? You get the moles first. You get the moles first. So you, kalau you buat macam ni, you boleh terus dapat mass dia, which is 7.875 gram. Kemudian yang ni lah yang kamu akan pergi dan timbang. Tadi dia kata 3 gram oxalic. So melalui pengiraan ni, it is 7.875 grams. So you go and weigh 7.875 grams of hydrated oxalic acid in a 50 ml beaker. Add approximately 30 ml distilled water. Dissolve, ikut sama step seperti dalam sini. Same sahaja. Sama seperti yang ini. Okay, the steps are equivalent to this. Just change the mass. The mass ni kamu kena tukar according to your question. Okay, stopper and shake. Kena fahamkan soalan betul-betul lah. So, minggu ni memang untuk fahamkan eksperimen ni. Ada soalan nanti you boleh tanya. How to determine the end point of the titration? How to determine the end point of the titration? Let's see. Alia, Nazira. How do you
Yes, madam.
how do you determine the endpoint?
The color changes.
The color changes to what color?
Pink to colorless.
Hey, from
Itu colorless to
pale pink.
to pink terbalik.
Bukan. Kena fahamkan betul-betul tu.
Okay.
From colorless to pale pink. And pale pink tu kena persist untuk berapa lama, Alia?
30 second.
Betul, 30 second. Kena fahamkan, betul. Tengok dia buat was pula. Nak buat surgery kat orang dah depan kamu baru kata, nak buat surgery kat perut ke kat mata ni? Okay, so please make sure the color must persist for 30 seconds and the color must be pale pink. Baru maknanya dia dah reach endpoint. So endpoint is the point at which the indicator changes color. So here your indicator yang you guna is phenolphthalein. So the phenolphthalein must change to pale pink. And pale pink tu kena kekal untuk 30 saat. Okay? Okay. The next question. Cuba buat ni. Okay, maybe you have not have time. Buat ni, kita akan discuss pada hari Rabu yang ni ya. Saya nak tengok macam mana kamu jawab ni. Saya akan pilih seorang untuk beri saya jawapan. Okay. So, is there any questions from you? I need you now to do this. Answer this jotter. Okay, draw your jotter. And then do the lab report sehingga sini for the next 1 hour. And I will also pass you in your Google Classroom the link for your video, for your lecture and the quiz question. So please make sure video tu kamu kena watch and I need you to comment. Comment on what is your understanding about balancing equation through inspection method, and beritahulah sesuatu, express, because I need you to express how you feel about that topic. Okay, if there's anything that you tak faham, boleh tanya. I hope you have tried kena buat latihan untuk balancing equation. Okay, wait before we San, ada apa-apa soalan daripada kamu?
No, madam.
No. Okay, wait 1 minute. I need to get your attendance. Sekejap ya, as I call your name. Sorry, I thought the timetable change a bit sebab tu saya pun macam keliru sikit 8 ke apa kan. 212. Okay, now let's see as I call your name. Please let me know if you are here or not. Okay, today is 16. Abdullah Fahim. Sorry. Fahim.
Okay. Yes, madam. Ada.
Dulu ada pelajar Fahmi sebab tu Fahmi asyik datang je ni. Adik Johan.
Yes, madam.
Okay, you are Johan kena Johan. Farhan.
Yes, madam.
Giri.
Ada.
Jamsir.
Yes, madam.
Okay, Lakshan.
Yes, madam.
Syafiq Hamdani.
I'm here, madam.
Okay, Afiq Haikal.
Yes, madam.
Okay, Syahmi. Mr. Syahmi, is he here? Tak ada. Okay, Nabil Akmal.
Yes, madam, I'm here.
Omar.
Yes, madam.
Okay, is Syahmi coming in? Oh my God. Good morning, Syahmi. Please PM me. Why are you coming in at this time, 9:30? Class 8 to 10, boy.
No, madam.
Kenapa lambat?
Tadi saya dah masuk dah, lepas tu yang ni terlepas pandang.
You macam
Sorry.
ada apa? CCTV kat bilik you. Masa I nak ambil kedatangan baru you sedar.
Tak.
Please make sure, boy. This is your picture. Okay. Okay, dah. Somfred,
Yes, madam.
Azri, Amira.
Yes, madam.
Oh, ada sound effect lagi Azri ya. Ada supporter tu. Okay. Anissa,
Yes, madam.
Farahin,
Yes, madam.
Najwa. Okay, good. Suhada.
Madam.
Ya.
Syuhada kata dia pergi tandas sakit perut.
Okay, tak apa. Tadi dia ada kan? Dia ada jawab. Okay. Alia Nazira.
Yes, madam.
Okay. Azwan Natasha.
I'm here, madam.
Yes.
Okay. Kenapa ada? Okay, ada sekretari untuk dia. Putri Ayu.
Yes, madam.
Shazwina.
Yes, madam.
Okay. So I consider that there's everyone except Mr. Shami. Please take note ya. Lain kali make sure. Okay. So what we are going to do now is there any question from you? If no, I will let you view sekejap sahaja the video sekejap ya. Tunggu just give me a minute. Tengok kalau boleh view Just give me a minute. Okay, so if you can see here, these are the apparatus. Kita ada burette, glass rod, white tile, filter funnel, weighing bottle, retort stand. Tengok retort stand dengan clamp dia macam ni ya. Benda ni kat tengah sini, we can keep changing it. Okay, then there is a pipette, analytical balance, volumetric flask and measuring cylinder. Okay, kita tengok. So HCl, NaOH, distilled water. press the tab, this blue button cancel the width of the bit. The display will appear with 0.0000 gram. The analytical balance is ready to proceed preparation of standard solution. Step 1. Read the level 0.0001 about 3.00 of height, approximately and equal. In order to prepare the solution, you will need measure glass rod, filter fiber, oxalic acid, and distilled water, and 250 ml of formulating flask. Step 1. Add approximately 30 ml of distilled water to dissolve oxalic acid. Approximately ni, we don't need to measure guna measuring cylinder ya. Pada beaker tu 30 ml approximate sahaja. Larutkan. You see how they pour? The solution. Pour on top. Plus. Repeat 2-3 times. Okay, see here. See, they use dropper. To obtain a homogeneous solution. Step 4. Calculate the concentration of the standard oxalic acid solution. Use this solution to standardize the sodium hydroxide solution. Standardization of 0.1 molar sodium solution. Certified by there are 2 types of pipette flow, high pump and pipette pump. Masa sekolah guna yang mana satu? Filler or pump? Sebelah kiri, pump. Filler, ha? I think most schools filler.
Yang ni macam mana nak guna madam? Kita kena picit tengah tu ke apa?
You akan picit, that means first you akan air valve tu, you akan keluarkan semua air and then you picit saja, suction. Suction kalau dia akan tarik lah. So S. So you tekan S tu, dia akan naik lah. Kemudian bila you nak empty, you tekan E tu saja. Tapi selalunya kita guna pipette filler. Okay, so you akan press A ni ya, atas ni dengan S ni. You nak hilangkan semua udara keluar. So when you do that, dia akan kempis ke dalam. You akan nampak bulb ni, dia suction bulb tu kempis ke dalam. Kemudian bila you tekan suction, dia akan naik lah. You see ya. Tengok dia kempis ke dalam. Inilah cara kamu rinse. followed by not sodium hydroxide, oxalic acid sebab kita nak pipette oxalic. Tengok cara rinse. Inilah cara dia, saya kata. Make sure dia mengalir. Jangan pula cucuk kawan kan. Kena hati-hati. Okay, you tengok ni cara dia isi, dia kena masuk ke dalam what you call that, the sink, so that dia tak tertumpah lah ke mana-mana. Yang air bubble ialah kat sini. Kalau you tengok sini, this part here, it should be terus sahaja. Dia tak ada apa-apa. Kalau dia ada air bubble, dia akan ada macam ruang udara kat sini. You akan nampak tak ada solution pada bahagian tu. Masuk tu ada air bubble. Kalau dia tak ada air bubble, dia full of solution only. Okay, ni tak ada air bubble.
Step 4, 125 ml of oxalic acid solution. Transfer the solution to a 200 add 2 drops of oxalic acid solution.
Okay, the titration part of it kita akan tengok next week lah. Saya nak bahagian preparation ni sahaja. So today you can see the preparation of how it is done. So macam mana kita cuci radar semua tu. In case kamu ada apa-apa soalan, kamu tak faham apa kegunaan dia ke apa, tulis and you can ask me, WhatsApp me. Okay, so now after this, there's another half an hour. I want you to finish up your jotter book. Please hand in your experiment 1 jotter dengan report in your Google Classroom. And after this at 10 o'clock, saya beri 1 jam sahaja. Semua orang kena tengok video tu lebih kurang 5 minit and answer the quiz question. Itu adalah kedatangan untuk kuliah. Siapa yang tak hantar, tak buat, di-consider tak hadirlah kuliah. Okay, so that's all for today. Have a wonderful week ahead. Bye-bye.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay, bye.